Assalamualaikum. Welcome to e-learning and Noor International School Grade 10 Chemistry course. I'm your chemistry teacher Fraz Anjum. In this way, we will study chapter number 13, States of Matter, and lesson number 3, the nature of the solid. Page books we need to review 431 till 434. So please open your book. Our main objectives are describe how the structure and the properties of solid related and identify the factors that determine the shape of the crystal. So let's start a model of solids. How are the structure and the properties of solid related? The general property of solids reflect the orderly arrangement of their particles and the fixed location of their particles, which is the most solid, the atoms, ions, or molecules are packed tightly together. That's why we call what is solid. So with the definition of solid, what is solid? So what we said, the solid have definite shape and definite volume because of this, because it's a tightly packed and proper shape. Doesn't matter you hang or you put in the table, it remain or maintain their shape. So it's called definite shape. Okay, and have the definite volume definitely. Okay, so solids are dense and not easy to compress because the particle is solid tend to vibrate about fixed point. Solid do not flow. These are the general example properties of. When you heat a solid, its particles vibrate more rapidly as their kinetic energy increases. So simple means heat, when you increase the heat, what will happen? The kinetic energy going to be increased and particles vibrate more rapidly. The melting point. So what is melting point? Is the temperature at which a solid change into the liquid. Simple. Easiest definition, what is it? When the solid change into the liquid, this temperature called melting point. So the temperature in which solid change into the liquid. At this temperature, the disruptive vibration of the particles are strong enough to overcome the attraction that hold them in a fixed position. Now what is freezing point then? The freezing point is the temperature at which a liquid change into a solid. So we are vice versa. Melting point, solid change in the liquid, and freezing point, liquid going to change into the solid. So melting and freezing point of a substance are the same temperature. At the temperature, the liquid and solid phase are in equilibrium. Okay, so solid change in the liquid, melting point. Liquid change in the solid, freezing point. Now, in general, ionic solid have the high melting point because relatively strong forces hold them together. Sodium chloride, an ionic compound, has a rather high melting point of 8 to 1 degrees Celsius. And molecular solids have a relatively low melting point, such as HCl hydrogen chloride, a molecular compound melts at negative 112 degrees Celsius. So you can see the difference. Okay, why it is? Because ionic compound has more strong electrostatic forces. Okay, and here is only weak hydrogen bonding. Checkpoint. Explain why solid do not flow, even though their particles are constantly moving. So answer is, in a solid, the particles are packed tightly together and vibrate around fixed points. Even though the particles vibrate, they are limited in their movement and cannot flow. Let's start about the crystal structure and the unit cell. What determines the shape of a crystal? So first of all, what is crystal? In a crystal, the particles are arranged in the ordinary, repeating and three-dimensional pattern called crystal lattice. Okay, so what is crystal? Crystal basically a solid which have a geometrical shape. So the shape of the crystal reflects the arrangement of the particles within a solid. In sodium chloride, sodium ion and chloride ion are closely packed in a regular array. The ion vibrate about fixed point in the crystal. So this is like a repeating unit, okay? Now, crystal system. But this is most important, this one, especially during when you go to the higher study in the university and college level. This is most important, especially for the civil engineers and the engineering purpose, okay? So crystal are classified into the 7 group of the crystal system. So we start with this. Number 1, cubic, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, and rhombohedral. So the most common is cubic. In the cubic system, cube says the all sides are equal. So side A equal to side B equal to the side C, and all these have a same angle, which is 90 degree. So alpha is equal to beta is equal to gamma, which is 90 degree. Alpha, these are called angles, okay, between this. So see the wall, what is it? Alpha angle, then beta, then gamma, okay, all are equal. Okay, so this is called cube. Same here, you can see in tetragonal, alpha A and B side are equal, but side C is not. You can see here, means A and B, this side equal to this and this side equal to this, both are same, but this is C is totally different, means the height is different, is longer than the others, okay? So side A, side B is the same, but side C is different. But angle you can see 90 degree for all. Now here rectangular you can say, okay, is called orthorhombic shape. Orthorhombic shape means all sides are unequal, but the angle still remain 90 degrees Celsius. Now look here, it's called monoclinic. All the sides unequal, and beta and gamma angle is 90 degree, but not like a alpha. Alpha is little bit narrow. Here triclinic, alpha equal to beta and not equal to gamma, means sorry, side A is not equal to B and side B not equal to side C, means all the sides are unequal, as well as all the angles are not equal 90 degree, is totally different, okay? Here is called hexagonal. Hexa means 6, okay? Hexagonal means 6 sided. Now in the hexagonal, basically you can say A side equal to B and side C is not equal to them. So alpha and beta 90 degree, but the gamma is 120 degree. Now alpha A side equal to B and B is equal to C, but the angles are not equal to the 90 degree, okay, which is called rhombohedral. Now the edges are labeled A, B, C, and the angles labeled alpha, beta, and gamma, as I explained. The 7 crystal system differ in the terms of the angle between the face and the faces, and in the number of edges of the equal length of each face. The shape of the crystal depends on the arrangement of the particles within it. The smallest group of the particle within the crystal that retain the geometrical shape of the crystal is known as unit cell. The crystal lattice is a repeating array, any one of 14 kinds of unit cell. Each crystal system can be composed of from 1 to 4 types of unit cell. So look at simple cubic system. The figure below shown the 3 kinds of unit cell that can make up the cube crystal system. So simple cube. In a simple cube unit cell, atom or ions are arranged in the corners of the imaginary cube. So see, all our ions or atoms are arranged in the corners. But body center, in the body center cubic unit cell, the atom or ions are the corners in the center of the imaginary cube. Okay, so you can see all the corner and then there is a one inside. Now face centered. In face centered cube unit cell, there are amount or ion which corner and the center of each face of an imaginary cube. You can say that each side have one ion or atom. Okay. Now allotropes. Some substances can exist in more than one form. These are called allotropes. Okay. Diamond is one crystalline form of carbon. The different form of carbon is graphite as well. So graphite, diamond, and carbon all together they called allotropes each other. Okay. So in 1985, the third crystalline form of carbon was discovered. This form is called Buckminster. Now check here. In diamond, each carbon atom in the interior of the diamond is strongly bonded to the four others. The array is rigid and compact. You can see here. In graphite, the carbon atom are linked in widely spaced layer of hexagonal array. So it's making the layers. And the Buckminster fluorescence, 60 carbon atom form a hollow sphere. The carbon are arranged in a pentagons and hexagon. So what are the allotropes? The physical properties of the diamond, graphite and fluorescence are quite different. Diamond is highly density and is hard, very hard. Graphite is relatively low density and soft and slippery, and hollow cage is fluorescent, give them strength and rigidity. So diamond, graphite and fluorescence are the crystalline allotrope of carbon. So allotrope are two or more different molecular form of the same element in the same physical state. Although allotropes are composed of atoms of the same element, they have different properties because their structures and are different. So allotrope, you can say simple that any two or more different molecular form of same element and the same physical state called allotropes, like carbon, graphite, and fluorescence. Now, only a few elements have allotropes. In addition to carbon, these include phosphorus, sulfur, oxygen, boron, and antimony. For oxygen, the most famous, this one is oxygen, like a oxygen molecule, like air gas, and this is very important for the Earth ozone layer. Okay, so ozone gas, this one. So these are allotropes. Okay, students. So not all the solid are crystalline in form. Some solids are amorphous. An amorphous solid lacks an ordered internal structure, like a powder form, not in the crystal form. Example, rubber, plastic are amorphous solid. Their atoms are randomly arranged, not in the pattern like a crystal. Another example of amorphous solid are glasses. A glass is a transparent fusion product of inorganic substances that have cooled to a rigid state without crystallizing. So glasses are sometimes called supercooled liquid. Remember, it looks like a glass is a crystal, but glass is not a crystal form. It's a supercooled. The irregular internal structures are intermediate between those of crystalline solid and those of a free-flowing liquid. What is the difference between an amorphous solid and crystalline solid? So, particles in a crystalline solid are arranged in an orderly repeating pattern or lattice. Particles in amorphous solid are arranged in randomly. So in crystalline, arranged properly, and amorphous randomly. The general properties of solid reflect the orderly arrangement and fixed location of their particles. The shape of crystal reflects the arrangement of the particles within the solid. So let's revise all the lesson. Number 1 point, melting point, the temperature at which the substance changed from a solid to the liquid. The melting point of water is 0 degrees Celsius. Freezing point, the temperature at which a liquid changed into a solid, means vice versa of melting point. Crystal, a solid in which atom, ions or molecules are arranged in orderly repeating three-dimensional pattern called a crystal lattice. And only crystal you can say which has a solid which has a geometrical shape. Unison, the smallest group of particles within the crystal that retain their geometrical shape of the crystal. Allotrope, one of two or more different molecular form of an element in the same physical state, like oxygen and ozone, are allotrope of the element oxygen. Amorphous solid, describe a solid that lack an ordered internal structure to need a random arrangement of atoms. Glass, a transparent fusion product of inorganic substances that have cooled to a rigid state without the crystallizing.